Hi, this is Rick for EDU Mobile. Today we're going to talk about the camera in Android Lollipop, some of the new APIs. Now remember, this is a high-level overview, and more detail will be furnished in the full Lollipop course. Here we go. So, chief among the new classes in the new camera APIs is something called Camera Manager. This is a system service manager for finding and connecting to camera devices. So context system or context camera service is what we're trying to get. So we get the result of get system service context camera service. This returns a camera service, but we need to cast it to a camera manager to get the camera manager. And then we can get a list by IDs as strings of all of the cameras attached to a specific device. Now this comes back as an array of type string. But this may throw a camera access exception. The full name of this exception is here. So we need to cast this in a try-catch block and catch Android hardware camera 2 camera access exception. Otherwise, your code won't even compile. It says this may throw camera access exception. So go ahead and get into the habit when you're using this camera manager, when you try to get the camera IDs, to go ahead and try catch this code. So camera manager, we are able to get the camera characteristics once we have these camera IDs. So we pass a specific camera ID to get camera characteristics, and this will return a camera characteristics object that we're going to talk about here shortly. We can also open a specific camera, and for that we need a camera device state callback to use once the camera is open, and then we need a handler, which is just going to be the handler where the callback is invoked. If we pass null for this handler, then we'll use the default main thread looper. So camera characteristics is a fairly complex thing because there are a lot of possible characteristics for a camera device. So this is a map. It's a key value pairing of all of the characteristics of the camera that you pass the ID in. There are over 60 keys in this map. We can get the value for a specific key using get because it's a list. So we use get camera characteristics.keyname, where keyname is the key you're looking for. Because there's over 60 keys, I'm not going to enumerate them here. Go ahead and see the link, developerandroid.com, reference Android hardware camera 2, camera characteristics.html for a list of all the keys and the values you can expect to get back from them. You can also, in your code, get this list of keys just by calling getKeys on the camera characteristics object for that camera. So, Camera Manager, as I already kind of said before, has an availability callback. And this callback really just contains two methods. Is the camera with that specific ID available, or is it not? So on camera available, you would override and see you get that string camera ID there. You would override this to respond to a camera becoming available if it has not been available to your app before. The default, of course, doesn't do anything. And on camera unavailable, again, with the camera ID as a string, you would override this method to respond to a camera no longer being available. Perhaps another app has captured the camera. So the default, again, does nothing. However, one caveat is that if the camera that you have attached to was available and then becomes unavailable for some reason, then the camera device, which we'll talk about here in a moment, the camera device instance for that unavailable camera ID will get a on disconnected call in its state callback. So we'll talk about camera device here in a moment, but I would suggest you read this or listen to this presentation a couple of times so that you get the full flow of what's going on. So Camera Manager finds cameras It enumerates all of their IDs. And then you can check for the existence and the characteristics of a camera with a specific ID, and you can check whether that camera is available or not using the camera manager's availability callback handler. Now we get to camera device. The camera device is a single camera hardware device that you have already found using Get Camera IDs, maybe selected a particular ID, open, and then you've got a camera device. The manifest must declare the camera permission in order for your app to use a camera device. It doesn't do this on a device-by-device basis. It uses permission camera. Hardware devices, though, can support one of two levels of capability, and these are called limited and full. Full means it supports the full hardware capabilities or the list of possible capabilities supported by the Lollipop camera device API. Limited means it does not. So limited devices, camera device will fall back on a kind of legacy camera device. Now, it still uses the same API, it still has the same functionality and convenience, but it mirrors the older camera API. So a limited device simply does not support the full list of possible capabilities of the full Lollipop specification for camera device. Full devices, however, do. They can take advantage of all the capabilities of camera device. So camera device is the software class that models the hardware device. So we have two ways of setting up the capture on a camera device. We can get what's called a capture request builder, upon which we can set a new surface. We get the builder, and then we build the device capture. So we set a surface for the output. We can set some parameters within this, but the capture request builder uses something called templates. So we get one of these things by calling create capture request with a type, which is going to be one of these things. Now, create capture request is going to return a capture request.builder object. So there are 6 different templates that we can create a capture request with, and they're pretty self-explanatory when you read the name, but I'll go through them here. Template manual allows you to set up full control of all parameters for the capture. Template preview just gives you a preview window. Template record is for video recording, pretty obviously. Template still capture is for capturing a single still shot photo. Template video snapshot allows you to record video but capture a frame as a still while you're recording the video. And then template zero shutter lag does exactly what it says. There is 0 time between the time that the user presses the capture button and the shutter snaps. So one option for capture is to get a capture request builder. Now, if this is not sufficient for the needs of your app, then you can fall back or do the actual capture session. So you can create a capture session by calling create capture session. That makes sense. With a list of surfaces. You only have one surface? Give a list with one surface in it. And this is called outputs. Camera capture session state callback, which we'll refer to here in a moment, and then the handler. The handler, again, is where the camera capture session state callback will be run. If you pass null, it'll run on the default main thread looper. The camera capture session is where actual camera capture takes place. The camera capture session state callback reports information about the state of the camera. So that is really all there is, except for the details of the camera capture session, which we can look up in the camera capture session API link given here. But that's really all there is to the new camera APIs. Camera capture session has a method called capture, It throws the image onto the surface that you set up or the list of surfaces and so forth. Thank you very much.